So let me start sharing the screen. Yes, here we go. Please give me, please let me know if you guys can see my screen. If my sharing is enabled, everything is
Yes.
perfect.
Yeah, sure. Perfect. Perfect.
Awesome, awesome. So I'm a MuleSoft senior instructor, and I'm also a senior integration architect and SME at NJC Labs. 20 years I've been into the IT field. I'm a certified architect and certified instructor for MuleSoft APAC. Now, today, what I'm going to focus is I'm trying to keep the session like in a level for a beginner to understand about integration. So, what I noticed most of the time in the industry today, the software industry today, people land up into integration space most of the time accidentally. Now, you have like a perfect career path to become a Java developer. You have a perfect career path to become someone like a database developer or a system administrator. But having said that, you become an integration developer or architect um, from, like accidentally most of the time. Many of not have like when they graduated out of the college, they would have never thought of, hey, I'm going to be an integration architect in the future. But yes, that's what the journey is. Now, if you take my case as well, I started my journey back as a system administrator, honestly. That was back in 2000. Gradually moved into programming, shell scripting, and later on, like into Java, big data, machine learning, and finally, last 4 years, purely into the integration space. Now, that journey is essential, and that really helped me to understand integration better and be successful in many of those projects I've been engaged with, and also able to reach to a position where I was able to teach architects. So I'll go into the basics in an understanding way that how what is all about integration. What is integration? Now, there is a famous book on integration, and all the patterns, all the various formats you can see in building up those components. Now, it's essentially called an enterprise integration pattern, and pretty much I will be in touch base with the patterns itself, but won't be strictly diving deep into it. But yes, simply put, integration is simply moving data from point A to point B. Moving data from point A to point B. And the easiest way to do that is with files. So everybody's familiar with it. And this is one of the integration patterns like file transfer. And hope everybody has done that at one point of time and still doing this. That's easy, right? You can move data physically from point A to point B, and you can, like old days we used to move it with floppy disk. Even like in India also, we didn't have like those kind of networks in the past, but yes, we have like now networks. So the floppy disk is some history of the past, but yes, we I personally had a lot of fun during that. One, we have the limitations. What is the size you can move? There was a DVD era, it's still in place. Like whenever you're watching movies, everything is still there. The pen drive is the most common way of moving data around. Portable hard disk for your backups, and something like there are still magnetic tapes around, which is essentially like a necessary component for enterprise data backups. So there you can store up to 15 terabytes of data, a collection of like many tapes. You can reach up to petabytes of data, but that is primarily for archives and backups. Now, it has become much more easier and simpler with cloud storage systems with petabytes of storage. For example, like you have Google Drives, Amazon S3 buckets, OneDrives, FTP servers can be configured, Dropbox. So you get like from gigabytes to terabytes of data storage now. I see there is no sound. Can you please give me a quick check if I'm audible?
Sure. Yeah, yeah, you're audible. Good to go. Yeah.
Audible. Okay.
Yeah.
So Nupur, can you please quickly check your audio settings? There's a high possibility that you have not given the permission on enable that on the Chrome or
Yes,
something.
yes.
Please
We'll
help.
just try once again, or just try logging in again. I think that will solve that.
Yeah. Okay.
Yes.
So yeah, this is much easier now. Okay, and this is one of the most, say, one of the most oldest of integration patterns still in use. But yes, can this be practical? Okay, so this was the go-to solution in the past, let's say in the 1980s, prior to 1980s, 1970s, 1960s, and it's still prevalent. But yes, let's do the math around that. Suppose like now today, in modern age, we are actually dealing with data from terabytes to petabytes of data. Now, what would be the effort that is required to move 100 petabyte of data? Let's say we have the fastest network available. It's higher than that, but let's say assume that we have a very good fiber optic channel which can do a 10 gigabyte per second. So the approximate transmit time that will take to move the data from point A to point B, in this case, maybe like a source system to a target system, even at a 10 gigabyte per second speed, is 3 months. Is 3 months. It's like you have the fastest network, but the data has grown enormously. And now these kind of patterns are happening like as we speak in different places around the world. This is like patterns of database migrations, data center migrations. So when it goes to those kind of scenarios, moving all the data over the network becomes a little bit tricky, it becomes hard. At the same time, you can expect everything that comes with the Murphy's Law. Anything that can go wrong will go wrong. So Amazon came up with this good, nice idea of Snowball and Snowmobile, and pretty much these kind of tools are used, these kind of systems are put in place to move data centers, like from organizations who host their own private servers. They want to move everything into cloud for numerous reasons. Use technologies like snowballs and snowmobile. Snowmobile is a truck where you can pack 100 petabytes of data and plug it into your data center, copy the data, go to an Amazon data center, unload the data. But even though that process looks so seamlessly simple, it takes time and it has got its own complexities. Now, even with simple files and when the size of data goes long, it has its own challenges. To start with, the file-based integration, it is one of the oldest styles of integration. It is still relevant. It is still used even today in many of the integration strategies. For instance, like think about cases like mainframes. You need to add data into mainframes. You need to extract data out of mainframes. Still the files are still it has got like fancy names like flat files and CSV files and so on, but that's still a most common relevant pattern. One of the most commonly used case for using this pattern is when you want to use data, whenever you have a use case of data migration. Now, when it comes to file, it is really energy efficient. The amount of data that you want to store over a period of time compared to storing it in hard disks or like distributed clusters and so on. Pretty much like you don't have to spend much of the energy in the case. For instance, magnetic tape, you can store the data and keep it like for long time. Okay, CDs, you can put it like long time. So it's an energy efficient way of storing the data, energy efficient way of storing data. Normal use case is backup and restore of data, maybe mostly in bulk. Okay, so one record at a time. It doesn't become much efficient, but yes, bulk loads, bulk updates. Commonly used in almost all ETL jobs, extract, transform, load scenarios. For instance, when you're using tools like other tools which are specifically designed revolving around this concept. For instance, Informatica is one of them. There is a Talent. So pretty much like data stage. So different tools to just perform this. Now, in the modern world, we use this exclusively, extensively in the analytics. Machine learning systems needs huge amount of data, and this huge amount of data normally are dumped into data lakes as files, mostly unstructured file. NoSQL is the king there. You have the big data systems, Hadoop, MapReduce, and machine learning systems to read data out of it, Keras, TensorFlows, and so on. And even for the logs as well, we use it extensively for monitoring purposes. For instance, what happens with the server with the peak loads. and the logs are coming like anything. Like the amount of volume of logs itself are huge nowadays to analyze all these things. Now there are different solutions for this. We will take it up on a different ways how to do this log aggregations, analytics, and so on. But we'll keep this into a lighter session. Now, one of the drawbacks of having a file-based integration, when it comes to seeking individual records, it becomes really difficult. It's always like searching a needle in a haystack. Imagine about like you have millions of files distributed over different places, let's say different data centers, for instance, and you want to see like a record which is spread across, or let's say a record like a customer, and the customer has invoice. The invoices are different files, and these are spread across different data centers. That's the case now also with the PDF files, and many organizations are still in that pattern. But yes, it's always searching like a needle in a haystack. When it comes to reliability, the reliability of the disk matters. Most of the time, disk tends to fail. Now, there are good architecture, hardware architecture in place, like redundant array of inexpensive disk RAIDs, okay, to make sure that the data is not lost with redundancies, but still there is a possibility to get your data corrupt. It happens once in a while, even in modern systems. With respect to performance, in certain use cases, files are the best in case of performance, especially when it comes to streaming media. For instance, you're all using YouTubes, all the systems, they use distributed file systems, caching. In conjunction with caching, you're getting very high performance, high throughput. But when it comes to enterprise level, it's not much of a weight. So it's performance-wise is a bottleneck most of the time. Wherever you see a file, there will be a batch. That's the normal scenario. When it comes to concurrently accessing the files, for instance, multiple users trying to read, fine, it's not a big deal. But when they start to write, yeah, we end up with immediate problem. With respect to APIs, this problem is called CQRS, Command Query Response Segregation. When it comes to a system level, it's just logs and logs everywhere. So whenever you're reading a file, whenever you're writing a file, you put a log so that nobody else can access that. That's normally controlled at OS level, but it becomes very difficult, like you automatically induce latency and all the associated problems associated with that. One of the biggest challenges with file systems is its numerous formats and the dependency on the hardware itself. Normal PCs, x86 architectures, you normally don't see this problem much, but when it comes to server-grade, enterprise-grade systems, you use totally different kind of processors, as not Intel all the way, all around, and there are different architectures when it comes to enterprise servers, mainframes, etc., and you automatically end up with this big Indian, little Indian problems, which dates back to the age of COBOL. Okay. Now, many of those things are abstracted now with high-level programming languages, but when it comes to integration, when we are moving data from point A to point B, all of these things become significant. Okay. So flat file schemas is one of the biggest challenges when it comes to ETL jobs, especially when you're dealing with mainframes and legacy systems. Not everything is new in the modern enterprise world. Some things date back like 40 years, 50 years, 30 years. Why are we still using ETL tools when MuleSoft can do the job? I would say each job needs its own specialized tools. Now, if the data volume is really large, you need to use specialized tools to do that. Okay, so for instance, DataStage or Informatica, these tools are designed for these purposes. Like you want to load like a terabyte of data or multiple terabytes of data. With MuleSoft, you can do that, of course, but use like the tools that are specifically designed for this. Okay. ETL jobs, we can do it easily. With batch jobs, it's available. Okay. I would go dive deep into the technicality of each and everything, which I will try to keep this at a high level. And in the following sessions, like which I would hopefully try to engage here, I will take you deeper into understanding the nuances of going on different patterns. So this is the high level, which will put you in a trajectory to understand which tool to use and how efficiently to use. That's in a nutshell. We will get here, even though with a simple introduction. Now, files are really good pattern if there was only one file format and only one type of hardware system. Format A without any translation could be accessed, read, etc. in point B, but that's not the case. So we have numerous file formats. Even for a text file, you will have different encodings itself. Even with text files also, you'll end up with special characters, ASCIIs, and so on. But yes, there are numerous formats. And the most commonly used is a translator pattern to do that. So you have a file of format A, which is converted into a file of format B. Normally, this is done today like at an abstraction level of drivers or libraries. But yes, essentially, this is the case. Now, this problem has boiled up into the internet space as well. So in the internet space, we have different protocols, we have different APIs and more. We see similar patterns at any other levels of channels or communication. Now, this is one of the patterns in the messaging patterns, in the messaging systems. This is a messaging translator in enterprise integration patterns. So let's have a look at these systems, how files were used previously. And as I travel back through the history and move it to the modern systems, you will see the similar patterns appearing over and over again, but in different styles. Essentially, like the integration patterns is pretty much remaining the same, only the systems and the levels at which they are participating are changing. So one of the old ways of accessing a shared resource as a common resource was putting it in a server and doing an RSH or remote shell or SSH or Xterm Windows or Citrix metaframe. So what is like you remotely logging into a server and accessing the resource? Now, this is quite common. Anybody who is working on, let's say, AWS, you're still using a CLI tool. If you're working with, let's say, virtual machines, the way you're accessing that remote machine between is using RSH. It's still relevant, but yeah, that's the way you're accessing the file. It's a form of integration pattern. But here, the server takes care of everything with respect to concurrency, multiple users, access, governance, and so on. But there are limitations with this, how much users can log into a single system. A few users, yes, 10 users, 100 users, 1,000 users. If it is like lightweight jobs, yeah, it can be done. But when the number of users increase significantly, we have problems. Okay. Now, when it comes to large files, you need to process it somewhere. So you need to process it locally because you don't have sufficient computing power in the servers, but the clients do have those powers. This evolution has came up with network file system concept, okay, where you share a file over like a file system over a network. Now, this system is also prevalent now. It has got like some fancy names, network storage and so on, but essentially the concept is, from when it comes to an integration pattern concept, is same. The files are stored remotely and processed locally. So the most commonly used network file system still in use today. When it goes into a server farms or data centers, you will see this widely used to have distributed storage with network file system, GVFS, even like our GitHub repo, it has a file system, a distributed file system. Then for the original name of GVFS was GNOME, VFS virtual file systems. It's pretty much used extensively in Linux. Google is using it a lot. CFS, your famous Windows, whenever you're sharing your file drive over your local network, shared drives, CFS, Common Internet File System. Okay, and a subset of that, superset of that, I would say, network NT file systems, new technology file systems. So this is remote mounting some disk into the job, and we still use these patterns, sadly to say, even today. So now the challenge with files is that it is difficult to organize and get a structured information out of it. Then that was resolved by putting database into place. And so was the arrival of SQL or SQL query, structured query language. You put like data, you create relationships between those, dump it into a database. The database will store it in files, hashings using best algorithms possible, binary search tree, BST, most commonly used, trees, that is the when it comes to data storage, especially databases, it's always the files will be stored, data will be stored in data structures known as trees. It can be binary tree, BSTs, and so on. But yeah, an efficient way of storing data and retrieving data. Again, the pattern is the same. You're moving data from point A to point B, and it initially started with SQL queries. So somebody want to get a record, you make an SQL query, you will get a list of records. Okay. Even today, also, this pattern is used. Whenever we have problems with data migrations, whenever we are having issues with failed records, when we try to move data from point A to point B using ETL itself, and maybe into a database, end of the day, we have to do a SQL query using the terminal to figure out like which record failed, which record succeeded. Okay, but yes, at the application level, it's lesser. It is encapsulated in applications with SQL queries embedded in it. But yes, if you want to be a developer, this is something that you have to know. You need to write good SQL queries, and especially like with all the things revolving around that with respect to inner joins, outer joins, and God knows what, stored procedure nowadays. So to make it a little bit friendly, people decided to put in applications in front of it. This was predominantly applications which were directly interfaced to the database system. And it was a kind of a tiny monolith system where you just access the data just using a single application. So most of the time, the database server and the application would be hosted in the same system, or it could be like a server could be, the database server could be remote and the application could be far away. Now, these kind of patterns emerged in tandem with when it was mainframes. And what happened, like as business succeeded, most of these technologies were used by business. When a business grew from one branch to another branch to another branch, let's say a business expanded from Houston to California to New York, the same application was replicated across. The database center, the data center remained the same, database became the same, but the application just got copied multiple places. It brings its own set of problem, but this is another integration pattern, a shared data pattern where you put everything into a centralized database or a collection of databases, servers, and each application reaches out to that for the single source of truth. It has its own challenges, especially when it comes to concurrent access and when concurrent modifications. Database do prevent some of the things, but human interventions normally cause many of the issues. For instance, let's say in this use case, let's say a user in California, maybe an employee, change the data in the table, it affects the business in Houston. Okay, so it's straightforward. You're just making a change in the database table, the pricing has changed, everything changed for Houston. So this problems was there, and to work around these systems, we had the rise of the ERP systems, and everybody would be familiar with the name SAP, which is a kind of king in the ERP world. Then the ERP, it was like, okay, I will build a big fat application which will help you to solve anything related to database. Pretty much it was an application that sits on top of a database, plus made it like more modular with different modules based on different strategies. We still use those kind of patterns, modular patterns, even in the kernels, even in web servers. ERP was in expanded versions of something similar to that. Now, initial designs were most of the time a server application and a client application with minimal functionalities, the server application with most of the functionalities, and pretty much that server application started to be the controller of data and access to that backend system. So earlier it was in the database pattern. If you take a step back and look at when it came to database systems, the control was either the control to the record or data was controlled using the database at record level, using the database administrations. When it comes to ERP systems, the ERP system started to control the access to the data. So the control part was shifted from this backend server system to another system or another server application. Now you will see this pattern of control moving back and forth across. Patterns like where you are putting control, where you are putting governance. It could be in the backend systems like a database, it could be in a middle tier or in applications. or it could be completely at the customer end. So Google is one example, like you're using Gmail, your authentication authorization happens at your web browser, but yes, it is validated against the backend systems. So the initial validation, like keying in something, it is converted to hash, if it is a valid pattern or not. Some of the job is offloaded into the client application. Some of the part is validated at the server level application, and some of it is validated at the backend level itself. Okay. So this pattern distribution of governance started with the rise of ERP systems and is still prevalent today in any integrations or any software systems that you use. Even with modern mobile apps or Android applications, this pattern is still prevalent. But yes, that journey started long back ago with the ERP systems. Now, one challenge with data is the complexity of associating, relating data from a table A to table B, and sometimes you may have to include complex logic to fit those data. Okay, that happens because of something called as domain-driven design problems. Um, in enterprise world, this is called, the famous terminology is um, big ball of mud. But pretty much like, you have the data, you want to keep the processing close to the data because you don't want to expose how this data is related to each other. Pretty much the reason being the data being dirty. So you put like stored procedures, and that was something propagated in the 90s, and it's still in use mostly. Like wherever you see modern integrations using the SOA methodology, you will see stored procedures or a collection of SQL statements put together as a single package and dumped into a database. You just make a call to that function, you will get all the data. But yes, that kind of integration patterns are still there today in modern systems. Then the rise of the internet changed everything. Okay, so earlier, like you need to build specialized client applications to access data or information. But with the advent of internet and World Wide Web, things changed drastically with respect to this client server kind of computing pattern. The distribution of distributed computing happened from a small scale to a large scale. So again, the pattern is the same. You're moving data from point A to point B, but yes, with different technologies here. You have your web servers put in place. Apache was the oldest one. Now Nginx is the king. The backend systems, you have every form of database now because of the scalability demand. It was all like an Oracle database or a MySQL or a Postgres database initially, but now you have like Cassandra, NoSQL databases, MongoDBs, everything put in place behind. It's not just one database anymore, it's numerous database systems, and in some cases even data lakes. Okay, so to serve all this huge demand. Okay, again, it was point A to point B. Now, at the time, like when it was server-side programming, like you used to have like Java server pages, active server pages, PHP, which is still in use. Okay, so if you're logging to many of the blogs today, even Facebook uses PHP, but these were some old technologies, just to tell you that it's all matured over a period of time. But yes, these were the initial forefronters. And somebody who died on the way, that was Perl. Okay, so which was initially a form of good way of writing APIs, as we see today, precursor of modern APIs. A Perl language was used to write CGIs, common gateway interfaces, which were otherwise hard to write with C or C++ language. Okay, so we've come a long way from there, and to a stage that, hey, like we don't have won't want to host everything in like physical servers. We can have virtualizations, we can dump all things in remote servers and manage it with the browser. Okay, so that's the rise of the cloud computing and containerizations. It started with virtual machines. Virtual machines became lightweight with containerizations like Dockers. There were a lot of container technologies in between, but Docker was just something that got the momentum. Amazon built their own virtual machine. There's the EC2 instances, as we call it today. We use extensively those systems in modern world. Google came up with this Google Kubernetes Engine, GKE. They have their own flavors of distributed computing. Azure, even though a Microsoft Windows shop decided to use Linux finally to build their infrastructure with respect to cloud computing. OpenShift, which was a derivative, came from Red Hat Enterprise Linux, Red Hat team for cloud, which was recently acquired by IBM. So Cloud Foundry, which was a precursor for any modern cloud foundations, it is still in use, called Pivotal Cloud Foundry. Somebody familiar from Java will be much, Spring framework would be much familiar with this. Pivotal is the guys who are backing it, but it's an open source tech. So pretty much like put everything into cloud. That was the next motto. But what happened there? We brought everything in the past, every pattern that we used to do in the past, and we made it virtual and put it in the cloud. So now the advantage is that like you don't have to physically wire things up. You can do all those messy things virtually with points and clicks. But yes, the patterns still remain the same one way or the other under the hood. Okay. So even if it is a modern technology, the architecture, many of the ways, maybe like some of the architecture is new, many of the architecture still remains the same as it is old. And integration is the space where we see everything. Okay. Now, what are the challenges right now in integration? What are the challenges of the past? We had a brief discussion about those. What is the challenges of the present and what is the way future? Now, when it comes to enterprise, a large organization, it's not about like one application or a second application or two applications, three applications. It's numerous applications. Numerous applications like from ERP systems to CRM systems to HCM systems, even analytics, reporting, you name it, there will be one. On an average, like there will be 500 to 1,000, 2,000, more than 1,000 in a modern organization. And with SaaS applications, with intervention of software as a service platforms, many organizations have a lot of systems now in place. Now, for a large organization to function properly, you need to have the data organized, right? So data should be consistent. It should be available in a consistent format across the enterprise. When you say modern enterprise, it is spread across countries. It's not just a region-specific organization. A modern organization is spanned across the world. Okay, so even if it is a modern .NET company, even though its operations may be just centric into a specific region in a small, tiny town, let's say in India, its operations will be large because it will be having customers from all parts of the world. Okay. So it's a distributed computing at a scale. Data needs to be consistent across all these different systems, relevant data. Data needs to be synchronized. You don't, for example, like if somebody withdrew like something from your bank account or your subscription account or your customer account, that needs to be reflected immediately, right? So that you don't overdraw or like somebody doesn't overcharge you in scenarios like that. So this becomes like consistency and synchronization becomes essential, and doing this over a lot of systems is a messy job. Data needs to be available. So everybody will be at some point of time have faced service outage, right? So you had your favorite website, you tried to go there and you see 503 not available or 500 or a 400 and so on. But yes, this is the common problem, like data availability of the data becomes a big challenge. Okay. When it goes into like small scale, fine, we can manage it. But when it go to scale at large, it becomes really challenging because a lot of moving parts needs to be dancing in sync to make that happen. Okay. Data needs to be accessible. Now, accessible in a sense, I would say the data should be controlled in with respect to access. Think about like what happens when an organization leaks the entire customer history, right? All the customers, all their credit card informations, all their date of birth informations, their address, and everything that the organization has acquired. So data needs to be accessed, but that should be accessed in a controlled fashion, so that no doesn't cause any harm. Okay, not for the organization and not for the end user as well. Okay. And now in the modern way, like we are now moving from like a reporting kind of architecture to more of would say an inferred kind of architecture where we actually using machine learning, mugging through a lot of data, processing tons of existing data, creating models, and building systems which can actually interpret or predict the future. But again, for those systems to function properly, you need to get clean data. And in data science world, there is a concept called data wrangling, where you get a lot of data, you clean up the data first to make sure that you can train a model properly so that it can infer the make inference from the data that is coming to it. Okay, so that's also a big challenge with respect to machine learning systems. There are like nice technologies, Python libraries to do it, but small scale, yeah, it does the job. Large scale, no, we need like some specialized platforms to handle those workloads, and that's where you come up with integration patterns. Okay. Now, regardless, like we just touched based on two patterns, that is using the files and the databases as the central piece of this. But in reality, like there are 65 different patterns that are used to connect, move data from point A to point B. Okay, and this is well documented in the book, Enterprise Integration Patterns. It's a good book to read to understand many of the patterns that is commonly used in the enterprises. But yes, one way or the other, every integration tool that you see in the market, regardless it is ETL tool or iPaaS or a ESB, end of the day, even point to point, at some point you are going to see this pattern embedded into that. Okay. Now there is an application A which want to send data into application B. Now application A cannot send it directly, it needs to package it first. So that is the message itself. Now there are different ways to construct a message. Some implementations may be having like only a small package of it. For instance, like let's say an HTTP browser, a browser is making a request to the server. You're making an HTTP request. The request will contain header. The header is a part of the message. You're getting a response back. You get response headers. That is a part of the message. You get a body that contains the data. That is another part of the message. Okay. So you pack data into a certain format and you send it. Now you cannot send it like just like that. You need to have a reliable medium to send it. So we have the internet protocols, or we have in enterprises we also use queues, message brokers as we call it, like ActiveMQ or Anypoint MQ or RabbitMQ. Okay, so there are different MQs. Anything that MQ, that is the queue where you're putting the message and it is fetched out another end. Now you want to channel the data, like you want to selectively route the data into the right place. That is the routing patterns, and there are different ways to do it. One is like a selective routing. If you get a message with this particular type of headers or with this particular format, you send it to target A. If it is not, you send it to target B. Selective routing. There is another pattern that is called a scatter gather, where you get a message, you want to send it to 10 target systems, you send it parallelly to 10 systems. So that is a scatter gather pattern. So there are different patterns that is there in the routing patterns in case of integrations. We will explore some of these in later sessions, like in coming sessions, and how it can be implemented in different ways and comparing the pros and cons of those at high level. Then we have the translator pattern. We saw that with the file, but yes, it happens at a message level. If you're dealing with files, the file itself is the message. When it comes to over the network, it becomes your packages. So message that contains your headers and your body, it acts as your translator. So you want to convert a data from a format A to format B. Modern day, you get data in JSON in format A. You need to transform the same JSON into another JSON with the format of B. The first format will be only containing like have the name as like first name, last name, all put together. But when it comes to the target system, it needs those fields separately. So even with the same data format, we end up translating. It's a translator pattern. One of the common with respect to integrations, there is a famous idea called canonical data models, which drastically reduces us to solve many of the problems. We will take one session for that. It's like one of my favorite topics to do that. And that's one of the reasons like many of the integrations fails as well, if you don't have the proper data model worked out. Okay, so that's essential for building good integrations, regardless of the technology. It's agnostic of technology. It's purely architecture, but I would spend some time on that like later this year sometimes whenever I do it. I do dictate a lot, make an emphasis of those in my trainings. Okay. So you somehow deliver the message to B. You want to check that if this message has been delivered properly or through the right channel or to the right time. You have all these monitoring puts in. Now, there are numerous applications to do that. like cloud-based applications are there, Nagios and all those things for monitoring. There are minimalistic tools as well. You can also use tools like Splunk, ELK, Elastic Log Stash, Kibana, to monitor, but that will be mostly like going through logs. There are active monitoring, passive monitoring, preemptive monitoring. But yes, it's kind of monitoring just to see that where the data is coming from and where it's going. So pretty much this is the integration patterns, 65 patterns. And whatever you see today is one way or the other abstraction of all these patterns. Maybe it has been all packaged into a single package, and hey, you click here, you click there, you get the data, move from point A to point B. Or some platforms provide you a little bit more control over how to do these micromanage these individual components, individual patterns. Anypoint platform, MuleSoft is one of those kind of patterns, but it's not a complete full point-to-point 65 based integration patterns, but rather than more high-level abstraction and user-friendly way. There is an Apache Camel, which is a ditto one-to-one implementation of this integration patterns. So a brief history of these integration patterns. Now we know there are numerous systems, numerous technologies, and there were efforts made from the beginning of time to connect these systems together. Sadly to say, we are still not there where we have 100% connected applications around. But let's have a look at what is a brief history. It all started with point-to-point integrations. We saw the files, and even today in modern world, even with the mainframe system still in use, we still have these files because that's the only way they can, mainframe system, many of the legacy mainframe systems can access data and give data. Okay, so if they want ingress of data, need files. They want to send something out, they need files, or message brokers, one way or the other. But yes, we have all the constraints that comes with files, even in messages as well. There are other famous technologies, which I don't want to name everyone, but yes, one is the Camel, which has been used extensively in point-to-point integration. Spring, that is extensively used. Node.js, the new baby in the integration world. But yes, another way of doing integrations with JavaScript. Then you have .NET, which is pretty much available in any organization who has a Microsoft product. Okay. So there are more technologies. I'm not going detail into the ESB platforms or the other integration platforms available, but essentially the point-to-point integration, this is the pattern. You take a point A, you take a point B, and you try to connect both things together using hard code, pure hard code. You write a single application which implements many of those integration patterns packed together into a single application. It's a quick win solution, but the only problem is that you end up with n square complexity, or you end up in a mesh. And that is something that is actually preventing many of the changes in organizations. You want to make a change in, let's say, an application C, it is so tightly coupled with other systems that you make a change in C, application A, application B stops working. You need to go and fix application A, you need to go and application B, and it will be like a small change. Let's say adding a couple of fields or removing a couple of fields is a 6 months job. Okay. To replace this, the context of software was viewed from a different perspective altogether. Okay, so this was more like, okay, so you are using a software for your hotel. It is more like a hotel service software than a hotel software. Okay, so the concept here was that, let's say each software is built for a particular service to serve. Okay, a particular service to serve. It could be like a customer experience. It could be like a list of products, knowing a list of products, maintaining a catalog. So exposing those as individual services, regardless how the application is internally built. That was the whole notion of going with the service-oriented architecture. And the success part of that you see today, you have a lot of SaaS applications, which are applications specifically built for individual service, customer relationship management, CRM. Okay, one example. Okay, then you have like numerous SaaS applications which can do like gives different types of functionalities. That's a high level, high end. But when it comes to enterprises, you group different systems together, Let's say this is a customer service, this is the customer, these are the customer services, or these are the product, these are the product services, this is the housekeeping, this is the housekeeping services. You club everything together in some way or the other using different layers of approach. And ESB, that was the thing that was used most of the time to achieve that, and give a single perspective of that service. That was the whole goal. The architecture was really good. It was perfectly in line with domain-driven designs, but it went wrong the moment people started to use it as a point-to-point integration tool. So there was nice architecture in place. This came back like 15 years ago or so, like last decade. But yes, all with that, like all the successful protocols like SOAP APIs, SOAP service, simple object access protocol, it named to something else later. So protocols came into place, HTTP APIs, REST APIs, everything was a byproduct of this approach most of the time. Okay. And but the problem was that end of the day, it all went into a single monolith application where that literally acted as a highway, information highway for the entire organization. The sad part was that even though the promise was to connect everything, the connectivity never happened. Architecture for it, and numerous reasons. Share the slide, you can see it like 10 reasons why this failed. It's not because of the architecture, it's because how it was implemented. Okay. So now we are in a bigger mess now. Okay. Now, after that, like, let's say instead of creating a service, a big fat service, let's make microservices. So this became like a hot topic the moment we got containerizations, Dockers, Kubernetes. Why build big applications? Well, we can build small applications, tie it all together, and create a big fat service. Certain organizations were successful in that doing. Amazon is a very good example of how a lot of microservices can be tied together and you collectively get a good solution. Okay, so A to Z of AWS service, Amazon Web Service, solve microservices under the hood. Netflix is another good example of microservices tied together. But yes, it comes with enormous complexities because earlier you had like 10 applications to manage. Now you have 1,000 different tiny applications to manage. At the software developer perspective, yes, this is a smaller APIs, fewer codes, easy to manage. But when it comes to putting it all together and integrating it together to give that experience or that service, it becomes a mess. I shared a link to a nice video about the history with respect to these microservices, how Netflix evolved, and the complexities that comes with microservices. If everybody says that microservice is good, it is good if used right. So we saw like out of all those different integration patterns, two things stood out. One is the SOA, which actually was the first time people started to see software systems as service, as a necessity to get a service done successfully. Okay, and largely because of, thankfully, because of the domain-driven design concepts and so on, architectures like software architecture moved away from that to a different approach. Hey, we should satisfy the business rather than fixing up, moving the data. From the data-centric approach, it moved into a service-centric approach. We can bring the data some way. That was the norm under the hood. But we can use those different data sets together, combine and provide a service. Microservices give a little bit more, like we can do it a little bit better way if we can govern it properly, if there is proper visibilities, and we can do the dependency management much efficiently. Okay, so these two patterns mostly was arrived, and that is the best way to go with right now and in the near future. Now, this is one way of going in the future. There are other ways like service mesh, but yes, going with a better approach that is with API-led connectivity. So what is API-led connectivity? We go with a very simple approach. Very simple approach. This is not a new approach. We saw this pattern like a few slides back. We saw very few APIs, right? So the three-tier architecture, everybody is familiar with the three-tier architecture. You have a model, you have a view, you have a controller. Okay, you have a view, you have a controller, model, view, controller. Okay, you
Shiva, sorry to interrupt. We have a question.
Go ahead.
When we are developing system APIs or experience APIs interacting via internet, does it mean we are developing microservices as well?
So I will get into detail of this. Okay, I'm just getting started on the API, so just need to wait for that. Okay, I saw that
Okay.
question. I was just waiting for this deck to complete. Okay.
Okay. Thank
Okay,
you.
so just raise like I will answer many of the questions after I present. Okay, with the better approach. It's a really complex topic. Okay,
Okay.
yeah. So here we have the API-led connectivity approach. It's a very simple approach if you look at it at the fundamental level. Okay. At the fundamental level, it is a model view controller kind of scenario. Okay. So you have an experience layer, you have a process layer, and you have a system layer. So let's take a step back and think about like how systems were designed in the past. It was you had a application layer, you had a presentation layer, you had a data layer. The purpose of the data layer was to abstract the data, backend data. The purpose of the presented layers was exposing the data, mostly the UI. Okay, and the responsibility of the application layer was to manage the complex business logic. Okay, when you do a microservice, when you do this at a microservice level, you end up still doing an MVC one way or the other. In a microservice, let's say you are building a Node application, Node.js application, or a Java application. You pack together the data associated with that application. Let's say it is a customer microservice, which is just giving you information about the customer. Let's say what is the total, let's say that customer purchased from an organization. Okay, so you pack the customer database. It may be like 10 or 15 records in the table, all together, accessing the writing the complex SQL, put it in a single query, and writing a simple application like a Node.js application or Java, or Spring Boot or something, and dumping it into a container, let's say Docker, and you run like 100 containers for your high availability requirement. There's a way of doing the microservices, but you end up tightly coupling everything, your experience, your process, your system, or the MVC all packed together. It's always a chaos one way or the other. Individually, that there is nothing wrong with the microservice, but collectively, when you have thousands of microservices all behaving in this pattern, it becomes difficult to connect everything together. Okay, so yes, of course we have APIs, we have standards, but thus, for a large organizations, large enterprises, it becomes significantly challenging to put it all together. Okay. Now, in API-led connectivity, we are taking the best of both worlds, best of the SOA world, where is service-oriented architecture, best of SOA, and best of microservices. That is, we can break things into smaller APIs, and we can get that service done. Okay, but in a decoupled fashion. And that's what exactly you're doing in API-led connectivity approach. You're abstracting the backend systems where there is the source of the data or source of service using layers of APIs, that is the system layer APIs, okay, which pretty much abstracts everything in the backend. So whoever is going to want to know about, let's say, orders, they don't want to know like the data is stored in Salesforce or the data is stored in SQL Server. An API will do the job for you. It can be a REST API, a SOAP API. In any one platform, there's a limitation, but yes, if you want to do it in microservices, you can go further along with other APIs as well. But yes, you need to take care of the additional governance and everything that comes around with it. But yes, in a controlled fashion, this is the easiest way. Now, every business, they need to change. Like change is a constant part in every organization. Today, the process of doing business is like this: process A, process B, process C. Tomorrow, you decide to get rid of process B. The entire process layer in the system needs to change in that case. Okay. You're removing a lot of things from the layer, or you're adding new things into the layer. So anything that is aligned with business logic that you're going to put in for an organization, it comes into the process layer. So as the business changes, as the enterprise business changes, as the way they do business changes, the business process layer API adjusts accords to that business changes without having an impact on the backend systems. If the backend system changes, that is the foundation itself, there will be changes that will be having impact. But here, because we have some nice things about API-led connectivity, that you have some standard data models put into play, it is relatively plug and play. Okay. So you can plug in systems, you can remove systems easily without causing a complexity. And towards the end, like the experience layer, which normally I would say like in enterprise layer, we are much concerned about at integration spaces, we are much concerned about the system layer and process layer. Experience layer, there are like numerous technologies. You can put Node.js, that's my say, but yes, not the official MuleSoft say, but it's my say. There are numerous ways to do it. You can write APIs in Node.js, I don't care. But enterprise level, we need to take it a little bit more seriously with respect to availability, reliability, management, and so on. But yes, you can have this. So experience layer is totally decoupling from the entire system. And pretty much at large scale, these two layers acts as anti-corruption layers for organizations. The experience layer prevent from the data, like incompatible data coming to the system and acts as a translator. The anti-corruption layer simply means glue code that convert is a message translator, which translate a format A to format B. So you are having like 10 different systems. You need a web browser. You need to put it in like an Android system. You need to access in desktop and blah, 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 wherever you want to do it. Experience layers will take care of translating that requirement to what we already have. That is our standard inside our enterprise. Now, any new system coming to our enterprise may not be having the same standard that we are keeping, like with respect to data models, data formats, data structures, table structures, fields. The system layer acts as a glue there, an anti-corruption layer to any system that is coming to an organization. Okay. And that layer, the process layer, that is the core of the organization, that is the business itself. So the business is protected at two layers, at an experience layer and a system layer with two different anti-corruption layers. Okay. So integrations, you always need this pattern, and there is a good videos later. I will share those links with respect to the complexities that brings in with this. Okay, so microservices is a little bit of overkill to say. It's just a small application running in a small container, but collectively application-led connectivity, API-led connectivity is connecting all those different microservices together in a meaningful way, not just in a short-term perspective, but in a long-term perspective. So when we're developing system APIs or experience APIs interacting via internet, does it means we are developing microservices as well? So everything that is, when it comes to system APIs and process APIs, we are now referring to the terminologies of MuleSoft. System API is essentially everything that you build in the Anypoint platform. If it is a cloud-based deployment, it's all APIs, it's all microservices. Now, how you want to build a microservices is up to you. You can pack the MVC together into a single API. That will be a ditto copy of the traditional way of building microservices in Java. Or you can choose this approach of segregating that MVC part into different ways, at the same time protecting the integration, organization's business with experience layers and system layers, which essentially acts as glues for, acts as an anti-corruption layer for the business. Okay, so that's a new approach, and it's a very simple approach, a simple style of integration. There are complex ways. The alternatives of this will be going with message broker streaming architecture, Kafka, which really doesn't go well in most of the scenarios, what I've noticed. Then you have the service mesh, which is controlling things at the transport layer, at the containerization level. That's another approach as well. But yes, with respect to large organizations, easy to build, easy to manage, API-led connectivity is the easiest way forward. It's an architecture style. Go for API first, a standard API first. That will be a REST API or a SOAP API, more of which we will have detail later on. System layers, putting it into 3 layers: system layer to abstract backend systems, a process layer to orchestrate your business logic, and experience layer to expose your service. On top of this Anypoint platform, if you're doing this in Anypoint platform, you get all the features that is required to make this happen, manage it well. So you have a look at the Netflix video, Mastering Chaos, and we will see some of the features available in the Anypoint platform. You'll see that it is perfectly capable using the Anypoint platform to maintain all these systems that you're building, especially for API-led connectivity. Okay, so that's the approach that MuleSoft is taking towards handling integration challenges in modern organizations with a very simple approach, not at all complex. Okay. Now, regardless to say, because this is one way of building a software, there is numerous ways to build the software. We saw that from the file system, from the database system, from pushing the processing to the client, to the server, and even to the databases, even in distributing layers. You can do it in numerous ways, but keep it simple so that it's manageable. Okay. So I will briefly go for a demonstration of Anypoint Platform, and this is fairly like to get you introduced into Anypoint Platform rather than learning A to Z of Anypoint Platform. Okay, so the easiest way to start on this is you can sign up for a trial account. If you have multi-screen, you can use this. You can always sign up for a trial account. It's free. Okay, like the way to learn Anypoint Platform is just one step away from you. You have many of these materials available free to start with. You can use any names, your name, sorry, file account, the email, okay, user numbers, your number, okay. Let's say so. I will give like these are all my from my trading accounts. Okay, so let's say 49, 50. Let's go for a 50. Yeah. Okay, and that's it. That's all you need to get started with the Anypoint platform and integration. Okay, so other places it's just too much. Like if you want to learn do integration in Java or any other languages, well, the journey is quite far. So here just start with the trial account. Okay, so easy to start. There's the advantage one. Now, the Anypoint platform has a lot of moving parts internally. Although it looks like a simple UI, okay, okay, okay. If you just look at Anypoint platform, it's just a UI, but underneath the hood, it is a lot of services running collectively together to give you the power to connect anything to anything. Okay, so it has got a lot of capabilities packed together just from a simple user interfaces, but it has got the capability to connect anything to anything and also build a powerful application network that is API-led connectivity, using API-led connectivity. To just have a look at what are the underlying services that runs, those are microservices and microservices built together. You can find all those services which are tied together to make it here, status.mulesoft.com. That will give you the complete list of services that are stitched together to give you this powerful platform. But you don't have to know each and everything to make an integration work. You can start from here. Okay, so basic, you want to connect, do a point-to-point integration. So we saw a file integration pattern. You can do that quickly. There is a design center. You don't even need an IDE. You can start it from there if you want to do the point-to-point integration. And the whole idea of the talk is not to do that, but yes, you can, if you want to do that, you can still do that, which is called with the create new Mule application. So in the Anypoint platform, everything is Mule. Start with the Mule most of the time. The Mule concept came long back because in integration, most of the time we do repetitive coding, that is donkey work, and that's where the name started. The founder and inventor of MuleSoft and Mule itself, Rose Mason, he was fed up with this repetitive iteration of writing Java codes, and he built on top of Spring framework. He put all the nice things that is needed to build good integrations, stitched it all together, created a package that was the Mule runtime, and the Mule applications started to make its way into integration space. It's like an old technology. It's not a new technology. The development started like back in 2003. It evolved now to a platform where you can just point and click and do integrations. Okay, so things were like not like that maybe like 10 years ago. You still had to do some extra Java coding to make things work. Still today also you need a little bit of extra effort when it goes into corner cases, but at enterprise scale most of this is sorted out with point and click. Okay, so let's say you want to make your a file to file application. Okay, so you need to file migration, and we call it like an application. Okay, so file migration application, to create that. So easy busy. Okay, easy busy. So we want to read a file from one place. Okay, so you get ready to use out of the box connector to start with. Suppose like your files are stored in AWS. Let's go for an S3 object. Suppose like I will just go to the canvas, straight to the canvas. Okay, since the canvas, that's where you're building the blocks of integrations. Let's say your file is stored somewhere in an FTP server. Okay, so we'll have a connector for that, FTP. Let's read the files from there. Okay, so you need to add the connections and parameters. I don't have any FTP servers configured at the moment, but yes, unique descriptive name. This is my FTP server. Connection type, FTP connection. Need to give some ports. I'm going for some random ports. Can anybody give me a class C IP address? Can somebody ping me a class C IP address? Class A, B, or C? Not class D. Okay, so there are like different internet classes. 192.168. Yeah, so we'll go for this. This is a local network, so just to case it, but this will not work in the cloud. Local IP address. Let's say, what is the standard port for FTP? Anybody? Standard port for FTP?
I think it's 2021. Sure.
21.
Yeah.
Okay. Yeah, we need a username and password. That's all we need. Okay, and there will be a directory. Okay. Let's say test directory. Put it. So yep, our application is ready to read from a source system. Okay. Now we need to implement a translator pattern. We can do that with a transformer. Here there is a powerful language called data V that can be used to do this transformations. Yeah. Transformer. You can get like data from whatever formats in formats, and you can convert it to the target format using this tool. Okay, and here we call it event processors, so we can process it with this event processor. And you want to send it to the target system, let it be another FTP server. Here it was a read operation. What was the configurations directory, FTP connector, or new file update. So whenever I'm getting a new files in that server, it should be read, should be transformed, and it should be dispatched to another system. Okay, so that would be another FTP server. Need to have a connector configuration. Every time a new file is created, transform, I need to create something new. Okay, so that should be right. That would do the job. Okay. Right, like new file something. Okay, overwrite it or append it or create new, whatever I want to do with it. Okay. I need to have some configurations also because this is a different server. FTP, need to add a new configuration. Okay, so for me, I'm just using the same one. Okay, so you read a file, you transform, you put. This is point-to-point integration. You can do this with clicks. Okay, so just like that. Similarly, like let's quickly build an API. Let's say we want to build a REST API. Okay. Now there are methodologies to do it. Like in MuleSoft, we strictly request to go with a spectrum development model. Okay. So let's create a simple API. Just it can be done with Flow design center itself. Okay. So new Mule application. Let's say this is my Calicut. Calicut experience API. Create that up. Okay. And let's start from there. Okay, so something that will take like some time to build it. Let's say how we can quickly build something. Just in case this is an API, it's not just Anypoint platform. It's not just APIs. It can do a lot of things. Anything that is related to moving data from point A to point B. The best possible way is doing with the nice, cleanest, manageable way is doing with API-led connectivity. But we can do any other stuff with Anypoint platform. Okay. But it comes with its own architectural cost. That's all. So here, let's say we start with an HTTP connector that listens to an incoming request. Let's say there's an HTTP listener. The target system. Let's go to Canvas. That's the easier way. So HTTP listener. HTTP listener that listens to hello, Calicut URL. Okay. It goes with some of the default configurations in Cloud Hub. There is a default configurations in VPCs. There is a different configuration. Not going into details of that, but yes, there's an endpoint which once I put into cloud should be accessible to you. Hello, Calicut. I need to give you a response that hello, Mules. Okay, so that will be set payload, or rather, I will get you started with database. Okay. That will be transform component. Pretty much the notations and everything is similar to that of JSON itself. Hello, Calicut. That should give me a response happily. Okay, ready to go. Now this language you want to learn more, there is easy to start with dw fun database fun dwfun.lang dwlang.fun. Yeah, that's it. Is essentially you can use it to transform data. Okay, so let's say like you have an incoming payload, let's say customer. Okay. And let's say this customer name is coming in small case. Okay, let's say a name Max Mule, and you want to make sure that this message is translated into upper cases. So that will be customer. This will be payload dot customer dot to customer so that should Max Mule to uppercase. Or we convert this to uppercase. Anybody from the data we've got? Let's have some fun. And we have to do these kind of things when we are translating the data. Okay, so upper. This is the link. So upper. There we go. Okay, so when we are moving data from point A to point B, we need to do a lot of transformations, enrichments. Enrichments is adding data or removing fields. So it's not just one field. You want to add more fields from different variables. There's a lot of context. Explore the DW fund lang place to explore what all things you can do with this kind of transformations. So, but here we are. Okay. So we can test our applications locally immediately. Just here itself. Okay. Preparing to test. This is a design environment to start with. A very simple example. Okay. Should be started. Yes, we have a temporary space to test our application. Slash hello Calicut. This is not working. Temporary environment. Let me see. Anyway, this should work in production, so I will just push it. Deploy application into my sandbox. That should do the job of deployments. Okay. So I've just deployed this application into CloudHub. CloudHub is AWS environment where you're actually deploying your applications. This is in US East region and it's getting deployed. It's my URL to start with. HTTP send. My endpoint was hello Calicut something. At the moment should be able to get the response, hopefully. If I didn't do anything stupid. And there you go, deploy. We have a maintenance window today. We won't be seeing the logs, but we will be seeing definitely the deployments. Deployment success is showing, but it just takes some time. Okay, that is spin up. Should be able to hit my endpoint and test it right away. Here we go. And this is there for you guys to access as well. So that's easy to build your APIs, apps, deploy into the cloud. Normally, like there is a good development process that goes into this when you're building complex applications, which will take us another day to look up. Okay. So yes, pretty much this is a Java application that we just built and deployed. End of the day, it is an integration application with integration capabilities. This is just an API to start with, a REST API. Not the best API in the world. I designed ideal APIs would be using good API specifications. But yes, that's the place to start with the Mule. Now, to make some journey easier in this world, okay, so what are the opportunities like if you sign up for this? Integration is a niche in the software development industry, and we need more and more people in this area. Okay. In Kerala, like the integration arena compared to other technologies, here like people prefer to be a Java developer or more like data science, like or go into data science or go into, let's say, web development, Angular, Node.js, Python. That's the trend here in Kerala most of the time. But yes, when it comes to enterprise, Java still rules. Java is the most essential technology, and integration is one of the most necessary stuff in organizations. Okay, Kerala, especially with respect to integrations, is a little bit opportunities are less in Kerala, but yes, those opportunities are coming in. But those opportunities will only come when you decide to move on to this. Okay, so with this meetup and with this introductory session, I would really like to bring that foundations into the community and bring in like new users and new users, new developers into the integration space. Pretty much the journey opportunities are just similar to any other software engineering. Just like you start as a developer, from there you can go into lead architects, senior architects, platform architects, and so on, technology managers, integration managers. The journey, like the bucks, most of the time stops around like being an enterprise architect or CTO, CIO. Okay, so that's the career opportunity here. Pretty much straightforward. Blockchain is totally a different stuff. Okay. Yeah, whatever you learned in blockchain will be useful, but it is more kind of technology that you can use to build a product. For instance, like what is the application of a blockchain in an enterprise? Yes, we need to store records, a lot of records, and it should not be tampered. We need to have like tamper-proof data. Okay, so if you try to do a tamper-proof database, it is difficult. But if you go for a blockchain technology, again, that is files. Okay, so you write in files. When you're writing in records, you chain the records together in data structure itself, so that you cannot change a record without, like affecting another one. That's what essentially you're doing with the blockchain. You're writing data into files only. Okay, so here, like we are doing this anyway. But yes, one is the application there. Okay, so no problem. Hope that answers your question. We use everything, like whatever technologies you learn, it will be all useful here in integration, because end of the day, our job is connecting everything to everything. What are the scheduling options, and what are there to schedule the experience APIs? See, like when it comes to scheduler, it's not actually called an API, it's called an application. Okay, an application which you can expose via REST API. So in that case, the REST endpoints acts as your trigger, or you go for simple things like schedulers. Okay, so in Anypoint platform, you have the schedulers, which will do the job of triggering that in like milliseconds, seconds, hours, days, whatever format you want to. Okay, so that will be not technically an API, it will be an app or application. Okay, hope that answers your question, Satya. Right. Yeah. Right. Okay. So opportunities. So pretty much the pays are high. The shortage of resources are very huge now, especially in India. India, we are catching up right now. Is human workflow intervention is possible in Mule using any console? Can you be a little bit more elaborate on that question, Chandan? Can you please unmute and
Yes, then I can give you access. Hello?
yes, go ahead, please.
Yeah, I think I've given Chandran access. If you can speak. I think.
Chandan, like I'm not clear about your questions. If you can explain a little bit more, I would be able to answer, because pretty much like in the goal of using APIs is to automate everything and minimize human intervention. But yes, it's just programming. You can intervene anywhere, anytime. End of the day, it is like fully under enterprise control, right? So you like here we control it with policies. You want to control access to any APIs or any environments, all you need to do is deploy a policy. Okay, we call it like a policy. You just apply a policy on top of an API, you can control access to that one. And within an application, if you want to control certain blocks, you may need to expose them programmatically using APIs or REST endpoints if it is an API. Okay, so numerous ways to control the applications are there, different patterns are there in coding itself. We can use any of those. Okay, so how you can get started on this? So MuleSoft do provides self-paced training courses. Okay, so those are all free courses available for you guys to sign up. All you need to do is use the login, go to training, and sign up for the trial account. Not this is for the trial account, this is for the training account. Sign up for the training account and you will be able to access all these resources. Okay, you will get everything from using getting started with the Anypoint platform. That's a 2-day self-paced. If you spend time, then designing the flow, the examples I did, you can build complex applications using that. You can learn that. And there is a fundamental course that is around 5 days, which is also free, available with videos, self-paced instructions, hands-down training. You can get started on this. But yes, still, like if you prefer to go with an instructor-led one, yes, there are instructor-led one trainings available. And for freshers at the moment, there are free trainings as well provided by MuleSoft. So if you are a fresher or a final year student getting out of college, to get you quickly into the integration world, MuleSoft is lending a hand by providing many of the instructor-led trainings free. But this is only for college graduates recently passed or in the final years. Okay, so in that case, if you want to enroll for something like that, you feel free to reach me out. You can connect with me on LinkedIn anytime, and just need to send us your resume. I will forward it to the MuleSoft team to help you get you started on that. Okay. So this is for the freshers only. Okay, so if you're experienced, sorry, can't help you. Yes, just the one. Okay, and towards the end of the things, meetups, we I believe like we also share vouchers, so that should help you get into trainings, instructor-led trainings. I mostly teach solution architecture and platform architecture for MuleSoft. Yeah, okay, and get certified. That certification has a really great value. Okay, which gives you great value. Okay, so that's all from my end. Don't want to take too much time. We actually reduced the content to half. Is it possible to integrate mainframe using Mule? Is binary transformation is available? So Chandan, like with respect to the concept of here, how to connect to a backend system is, if possible, try to connect straightforward. So the straightforward way is using a connector, that is pre-built connectors that are available in the endpoint platform, which are provided by MuleSoft. One of those example is IBM. If you got it like AS400, IBM, there will be CICS, that's for mainframe, IBM Maximum, MQ connector, CCS, or pretty much these are all for the mainframes. Okay, so also you can get the data, any format, it can be transformed and done that. But yes, if it is like, again, like I mentioned about the little Indian, big Indian problems. So if it is COBOL copybooks, we'll see like the similar challenges dealing with those kind of files, but there are toolings around that to handle those kind of systems. Yeah, it's pretty much easy. So S400 connector, have to connect to S400. It's straightforward. Okay. And there is a connector for almost every standard enterprise application. SAP, look for SAP, there's SAP connectors. So start with. All right. A little bit slow. SAP, again, like there will be connectors. Okay, so suppose every standard application you'll find like common connectors to use with. Yes. Yeah. Any other questions? All
I
right.
think we don't have any questions in chat, Shiva. So if anyone wants to, speak up or ask him something, I can very well give you the presenter access. So if there is anyone out there, you can let me know in the chats.
Okay, guys, then like
yeah,
thank you.
Yeah.
Thank you, John. Thank you guys, like for spending some time with me. Yeah, looking forward. John, like you can take back the
Yes, you
control.
can. Yeah,
I need
you
to
can.
stop sharing, right? Okay.
Yes, yes, yes.
Yes,
So
listen
yeah.
to you. Yeah, back to you.
So yeah, my screen is visible, right, guys? I can see. Yes.
Yes, John.
Yes. Okay. So thank you, Shiva. Thank you so much for that awesome session and your valuable time. So we are going into a trivia quiz. So before that, I just need to tell a few things about with regard to the quiz. So according to the latest rules for MuleSoft meetups, if there is anyone out here who has won the voucher for the last 30 days with any MuleSoft meetups or other events with respect to MuleSoft, even if you win today, that will be considered void. So I'm just giving a heads up on that. So I'm just repeating, if there is anyone out there in the list who has won the voucher in the last 30 days, even if you win today, that will be considered void. So maybe it's a better thing we can give chances for the people who has not won yet. Yeah. So the basic rules are, I'll be displaying the question. The next slide, you'll be seeing the question and there will be options, namely A, B, C, and D. So you just have to type in your answers in the chats. As
Yeah,
simple
in
as
the
that.
general section. Yeah.
In the general section, yes. You have to just type in your option. So the person who gives the right answer, the first person who gives the right answer, that will be considered. So maybe I can draw a separator there. So, is the separator visible, Fatima?
Yeah, I added one.
Hello? Guys, can you see a separator or something? Can someone respond to me?
Hello, John.
Yeah.
I'm not able to hear you properly. I think there is some issue with my net.
I think I'm drawing a line. Okay, you can see a line now, right, guys? Yes, I think I can see a line. Yeah, thank you. Maybe you can stop now. You can stop now. So after that line, now I'll be displaying the questions and you can give the right options. Okay. So going to that. So this will be the first question. Yeah, that's it, guys. Thank you. Yeah, I think we'll be taking the first person. Yeah. So it's Rajni Yerva. So congrats, Rajni. So you can put in your mail ID in the chat towards the end of the session. Maybe not now. Yeah. Thank you, Rajni. Congrats. Thanks, guys. Other ones for participating.
Congratulations.
Congrats, Rajni. Yeah. So I'll draw the second separator. Yes. So we'll go to the next question. Okay, that's it, guys. I got the answers. Yeah. Yeah, you can stop the guys. Yeah. So it's Siddhant. It's Siddhant, right, Fatima? Just confirming.
Yes,
Yeah.
it's
Thank
Siddhant.
you. Yeah. Siddhant, congrats. The answer is B. That is not a default port of database. That's a wrong port, actually. Yeah. So thank you, Siddhant. Thank you all others for participating. Yeah. Siddhant, you also can give me your mail ID towards the end of the session. So that, yeah. Draw on the separator. Yes. So we'll go to the third question now. Okay. It's Giridhar, right?
It's Giridhar, yeah.
Giridhar. Yeah. Congrats, Giridhar. Congrats. So thanks everyone else who has participated. Yeah. Thank you. So that's it. We have the three winners. Thank you all guys. Yeah. Okay, so that's it. So all of you can just put in your mail IDs in the chat so that I can get back to you later. Asking you for further details. Thank you guys. So that's it. We are done with the Fatima?
No. I was just going to say about the email ID. Yeah.
Yeah. So the next thing is, it's the wrap up. So guys, so we really do love feedback. So whatever it is, please do give us the feedback. You'll be getting a survey mail after this. So just that is going to support us, help us come back with more great topics. So, and you can also give great suggestions about the topics, if you have anything at all. So, and then you can tweet anything if you want, if you would like to, with the hashtags MuleSoft Meetups as well as Calicut MuleSoft Meetups. And yeah, that's pretty much it. So yeah, just reminding you again about the survey that you're going to get. Yeah. Yes, that's pretty much it. Thank you guys. Thank you everyone for joining.
Thank you, guys. Thank you, Shiva, for the session.
Thank you. Thank you guys. Thank you.
Thank you all.
Thank
Catch you
you.
guys soon.